In this video, I want to explore how we can use the properties of logarithms to expand a logarithmic expression. Recall there are three essential properties of logs that we will apply. The first is that the log base b of a product xy is the sum log base b of x plus log base b of y. The log base b of the quotient x divided by y is the log base b of x minus the log base b of y. And lastly, the log base b of an exponential expression x to the r is r times the log base b of x. Recall these properties come from properties of exponents. So when we see this expression, which is the natural log of the quotient, the fifth root of xy, divided by a to the fourth z. The first thing I want you to notice is that the argument of the log is a quotient, which means we're going to rewrite this as the natural log of the numerator minus the natural log of the denominator, which gives us a natural log of the fifth root of xy minus the natural log of a to the fourth z. Then we can rewrite the fifth root of xy as an exponent. Recall this means the natural log of the quantity xy to the 1/5 minus natural log a to the 4z. Now we have two other properties we can apply. In the first expression, the argument of the log is raised to a power, so we can use the property that states that that exponent is going to come down to be the coefficient of the log. So this would be written as 1/5 times the natural log of xy minus, now we can rewrite the natural log of a to the 4z using the sum of logs because the argument is a product. So we will need to put this in brackets because the subtraction sign will apply to everything that follows. This gives us, in bracket, natural log of a to the 4 plus natural log z. Then when we rewrite 1/5 times the natural log of xy, notice that the argument is still a product, so we need to rewrite that as the sum of the logs. So this coefficient of 1/5 will apply to what follows, so be sure to put this in parentheses or brackets. So we have 1/5, open parentheses, natural log of x plus the natural log of y. Then we'll close parentheses. Now we're going to distribute the negative sign to the sum that we had just written, but also applying the power rule here that the natural log of a to the 4 will be written as 4 times the natural log of a. So distributing the negative, we get minus 4 natural log of a, then minus natural log of z. And lastly, we can distribute the coefficient of 1/5 to get 1/5 times natural log x plus 1/5 times natural log of y minus 4 natural log a minus natural log z. So our goal in expanding these logarithmic expressions is to continue applying the three properties of logs until the argument of each log is no longer a product, quotient, or exponential expression.